Hello, welcome to lecture 10. In this lecture, we're going to do something slightly differently. We're going to just look at how torch.compile works in terms of invoking the forwards and backwards graphs. And the reason why I want to do this is because as we're debugging deep tensor, or in general, trying to understand how PyTorch works, it's really useful to know the entry points. And as we've seen, the compiler is a nice way to capture the full graph and see what's going on. And so it's quite useful sometimes, for example, to be able to breakpoint in the forwards or in the backwards and inspect what's going on. And lastly, this is something I wish someone told me earlier. So I'm going to tell you now. So at a high level, when we torch compile something, we generate bytecode that basically knows how to grab data from a variety of different places, including global variables, the function inputs, class attributes. And we generate bytecode to basically generate a single tuple of args, which we will then pass into our compiled region. And our compiled region is basically a custom AOTAUTograd function, which we saw 2 lectures ago, where you have a forwards and a backwards. And so when you invoke the compiler, when you invoke your compiled region, it goes to the forwards, you get some output, and when you call backwards on the output, that will invoke the AOTAUTograd engine, which will then invoke the backwards. Okay, so now let's look at some code. So here is the code from the last lecture. And as we see, when we invoke this compiled function, we go through a bunch of wrappers, and then we get to this part. And at this part, Dynamo has already, ran the bytecode, or the bytecode Dynamo generated has already run. And we can see here that we have a tuple of args. In this case, it's pretty simple. We just have these d-tensors. And if we go deeper down the stack, we can see that eventually it invokes this class compiled function, which is a subclass of an AOTAUTograd, custom AOTAUTograd function. And indeed, we actually do go through this forward, and then we call it this. So this is kind of interesting. This is what's called boxed calling convention. You can read more in a PR, which I guess I can link in the description. But at a high level, sometimes we'll convert from the tuple to a list because it allows us to free memory as we're going through the backwards. So yeah, and then if you scroll down here, you'll see later on that there's actually backwards as well. And so if we jump forward, we'll see that once we get to this loss.backwards, when we run it, it will call engine.backward. And then boom, we're back. And so now we're in the backwards of this compiled function. And then we can print out flat args, and we can see that that is going to be kind of our gradient flowing backwards. So hopefully this was helpful. This is just kind of like a nice debugging tool, a nice way to kind of inspect what's going on for what's going in and out of the compiled region. I'll see you in the next lecture.